Hi friends, welcome to all. In this video, we are going to discuss a CCNA version 7 packet tracer activity, HSRP configuration guide. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any technical or project support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Now, coming back to our activity, here we can see our addressing table. The I-net router is present in the internet cloud and cannot be accessed in this activity. Okay, here they given that interface its IP address. Okay, and they specified it's in this internet cloud. Okay, that's right. So coming to the objectives, in this packet tracer activity we will learn how to configure hot standby router protocol, that is HSRP, to provide redundant default gateway devices to host on LANs. After configuring HSRP, we will test the configuration to verify that the hosts are able to use the redundant default gateway if the current gateway device becomes unavailable. So we will configure an HSRP active router, then we will configure an HSRP standby router, then we will verify HSRP operation. Just we will go through this background. Spanning tree protocol provides loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if a gateway router fails. First hop redundancy protocols, that is FHRPs, provide redundant default gateways for end devices with no additional end-user configuration necessary. By using a FHRP, two or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. In this packet tracer activity, we will configure Cisco's hot standby router protocol, that is HSRP, which is an FHRP. We will configure HSRP on routers R1 and R3, which serve as the default gateways for the host on LAN 1 and LAN 2. When you configure HSRP, we will create a virtual gateway that uses the same default gateway address for host in both LANs. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. Because the hosts on the LANs are configured with the IP address of the virtual gateway as the default gateway, the host will regain connectivity to remote networks after HSRP activates the remaining router. Yes, so here all they talk about HSRP. Now we will go to instructions. In part 1, verify connectivity. Step 1, trace the path to the web server from PC-A. Go to the desktop of PC-A and open the command prompt. Then trace the path from PC-A to the web server by executing the traceset, the IP address at 209.165.200.226 command. Which devices are on the path from PC-A to the web server? Use the addressing table to determine the device names. Okay, we will use this traceset command. I will copy this command. Then coming to PC-A, we will go to command prompt and you will paste it. Then press enter. Tracing route to the server. And here we can see trace complete. We will identify these devices using our addressing table. So coming to our addressing table, here we can see the first address 192.168.1.1. This is a default gateway to that PC-A, that is R1. So just 192.168.1.1. Here we can see that it's a device R1 interface G0/1. The next address is a 10.1.1.2. Here we can see that address 10.1.1.2, interface G0/0 in this router R2. So from PC-A it goes to S1, then it goes to R1, then it goes to R2. Then we have a 10.100.100.2. It's here, inet, which is in the internet cloud. And finally it goes to this server, web server, right? Yes. So once more we will see the path. It starts from PC-A, then it goes to S1, then it will go to R1, then R2, then it will go to the internet, and finally it will go to web server. Now in step 2, trace the path to the web server from PC-B. Repeat the process in step 1 from PC-B. Which devices are on the path from PC-B to the web server? Okay, we will repeat this same step. We will trace to this web server from PC-B. Click on PC-B, go to command prompt, and we will paste that command here. And it goes to 1.3. Yeah, because of my selection it gone. Just again we'll give that tracer here. Yeah, here we can see that. Now we will identify these devices 192.168.1.3. Coming to our addressing table, 192.168.1.3. Here we can see interface G0/0 and the device is R3. So from PC-B it goes to S3, then it goes to R3, right? Then from R3 we'll close PC-A, and here is PC-B. Yeah, then it goes to 10.1.1.2. 10.1.1.2, that means R2. Then it goes to this R2. Okay, then we can see it goes to 10.100.100.2. It's in this internet. Okay, then finally it goes to our server. Yeah. Now coming to step 3, observe the network behavior when R3 becomes unavailable. Okay, select the delete tool from the packet tracer toolbar and delete the link between R3 and S3. Okay, we are going to delete this link. Okay, just to press delete and we can delete this link. Now we will open a command prompt on PC-B and execute the traceset command with the web server as the destination. Okay, so we'll go to PC-B again, command prompt. We can press up arrow from keyboard, up arrow, then press enter, and we are waiting for the traceset. So compare the current output with the output of the command from step 2. What are the results? So it says request timed out, and we can see this PC-B lost the connection to its default gateway. So we can see request timed out. Okay, next click the connections icon in the lower left corner of the packet tracer window. Locate and select the copper straight through icon in the palette of connection type. Then click on S3 and select port gigabit Ethernet 0/2. Then click R3 and select port gigabit Ethernet 0/0. So coming to our packet tracer, here we can see connections and we will choose copper straight through. Then click on S3 and select G0/2. Then connect to R3 G0/0. After the link lights on the connection are both green, test the connection by pinging the web server. The ping should be successful. Okay, here now we can see the link between this S3 and R3 in green. So we'll go to PC-B and here we can see trace complete because we connected the network. Anyways, we'll have a ping to this server. So just I will copy this address, ping to this web server, and we can see we get the replies. It succeeded. Now we will go to part 2, configure HSRP active and standby routers. Step 1, configure HSRP on R1. Configure HSRP on the G0/1 LAN interface of R1. We have to give this command. We have to go to that interface G0/1, then specify the HSRP protocol version number. The most recent version is version 2. They given a note, standby version 1 only supports IPv4 addressing. Okay, we have to give that command, standby version 2. We will go to router R1, enable conft. We will go to interface G0/1 and we will set the standby version 2. Okay, then configure the IP address of the virtual default gateway. This address must be configured on any host that require the services of the default gateway. It replaces the physical interface address of the router that has been previously configured on the host. Multiple instances of HSRP can be configured on a router. You must specify the HSRP group number to identify the virtual interface between routers in a HSRP group. This number must be consistent between the routers in the group. The group number for this configuration is 1. Here we can see that configuration standby 1. Then we have to specify the virtual IP address, IP space, then the virtual address. We will do this configuration. It's standby 1. Then we have to specify IP, then virtual IP address 192.168.1.254. Then press enter. Now coming to D, designate the active router for the HSRP group. It is the router that will be used as the gateway device unless it fails or the path to it becomes inactive or unusable. Specify the priority for the router interface. The default value is 100. A higher value will be determined which router is the active router. If the priorities of the routers in the HSRP group are the same, then the router with the highest configured IP address will become the active router. So we have to set the priority, and here they mentioned that the default value is 100. So we will set standby 1 priority as 150. We will set this priority in this R1. Standby 1 priority 150. Okay, so R1 is now our active router. R1 will operate as the active router and the traffic from the two LANs will use it as the default gateway because we set the highest priority in this router R1. Next is if it is desirable that the active router resume that role when it becomes available again, configure it to preempt the service of the standby router. The active router will take over the gateway role when it becomes operable again. So we have to give this command for that, standby 1 preempt. Okay, we will give that standby 1 preempt. Next is what will the HSRP priority of R3 be when it is added to HSRP group 1? Yeah, it will be obviously 100 because here mentioned that the default value is 100, right? Yes. Now coming to step 2, configure HSRP on R3. Configure R3 as the standby router. Configure the R3 interface that is connected to LAN 2. Repeat only steps 1B and 1C above. That means we have to set the version and we have to set the virtual IP address, right? So we will go to R3 and then we have to go to this interface, that is a G0/0. Okay, enable conft, we will go to interface G0/0, then we will set the version standby version 2. Also we will set this standby 1 IP, then virtual IP address standby 1 IP address is 192.168.1.254. Now coming to step 3, verify HSRP configuration. Verify HSRP by issuing the show standby command on R1 and R3. Verify the values for HSRP role, group, virtual IP address of the gateway, preemption, and priority. Note that HSRP also identifies the active and standby router IP addresses for the group. So here they given this show standby command on R1 and shown the output. So here we can see the details. Even they given the output for this router R3 also. Okay, so just we'll go to R1 and we will verify it. Give the command ent show standby, and here we can see the details. We can see gigabit Ethernet 0/1, group is 1, version is 2, and we can see its state is active. Okay, and here we can see its virtual IP address. Also we can see active virtual MAC address is set, and here it shows the local virtual MAC address. Then other details, active router is local, that means this is the active router. And we can see standby router, that is 192.168.1.3, that is router R3, and here we can see its priority, it's 150. Okay, now we will go to this router R3. We will give end, then we will give this show command show standby, and we can see the details. Here we can see its state is standby, then we can see its virtual IP address. Also we can see active and local virtual MAC address, and here they mentioned the active router, that is 192.168.1.1, it's R1, and here we can see its priority, it's a default priority, that is 100. Next is using the output shown above, answer the following questions. Which router is the active router? Yes, we have seen it's R1, and we can see in this show command itself state is active, so it's R1. Then what is the MAC address for the virtual IP address? Here we can see that MAC address. Okay, then what is the IP address and priority of the standby router? The IP address of the standby router we have seen, it's we have seen in R1, it's standby router 192.168.1.3, and we can see its priority. So if you go to R3, here we can see its priority 100. So this 100 is the default priority. Now use the show standby brief command on R1 and R3 to view an HSRP status summary. Sample output is shown below. Okay, just we'll verify on both routers. Show standby brief, and here we can see the details. So interface, we can see the group, its priority, state is active, standby, we can see its address, and here we can see virtual IP address. Next we will go to R3. Show standby brief, and interface is G0/0, group is 1, priority is the default priority, that is 100, and this router state is a standby. Then we can see active router address 192.168.1.1 standby, so R3 is in standby. Then we can see its virtual IP address. Okay, now we are going to change the default gateway address for PC-A, PC-C, S1 and S3. Which address should you use? Obviously, we have to use the virtual IP address we given, that is 192.168.1.254. Verify the new settings. Issue a ping from both PC-A and PC-C to the web server. Are the pings successful? It should succeed. Anyways, first of all, we will change this default gateways. First of all, we will go to PC-A command prompt. Sorry, we have to go to IP configuration, right? So here we have to change this default gateway 192.168.1.254. Okay. Now close this PC-A. Then we will go to PC-B IP configuration and change its default gateway 1.254. Next, we will change in these switches S1 and S3. Click on S1, enable conft. Then we will set the default gateway, IP default gateway. It's 192.168.1.254. Then we will go to S3, enable conft IP default gateway 192.168.1.254, the virtual IP address. Now we will go to part 3, observe HSRP operation. Step 1, make the active router become unavailable. Open a command prompt on PC-B and enter the command traceroute 209.165.200.226. That means we are going to trace from PC-B to this web server. Does the path differ from the path used before HSRP was configured? We will check that. We will go to PC-B, then we'll go to command prompt, and here we will press up arrow, again press up arrow, so traceroute command, and we can see it goes to 192.168.1.1, then it goes to this, then here, then finally to our, so just we'll go to our previous traceroute command, and we can see it goes to 192.168.1.3. that means it goes to the router R3, but here now we can see it goes to router R1, because that is the that is the active router, right? Now coming to step 2, break the link to R1. Select the delete tool from the packet tracer toolbar and delete the cable that connects R1 to S1. R1 to S1. Okay, we can do that. Just press a delete button from keyboard, or you can select from the toolbox. Just give delete, and we are going to delete this connection. Then press escape. Okay, then immediately return to PC-B and execute the traceroute traceroute 209. that means we are going to traceroute to web server. Okay, then observe the output of the command until the command completes execution. You may need to repeat the trace to see the full path. Okay, again we will try in PC-B. We will go to PC-B command prompt. So again press up arrow and press enter, and we just wait for the result. Now we can see it goes to this router R3 because the active router is unavailable. So this standby router become active router. Okay, that's why we get this address 192.168.1.3. then it goes to this router, that is R2, then to this internet, then finally to this web server. How was this trace different from the previous trace? Yes, now it goes to PC-B, then it goes to R3 because R3 become the active router. HSRP undergoes a process to determine which router should take over when the active router becomes unavailable. This process takes time. Once the process is complete, the R3 standby router becomes active and is used as the default gateway for host on LAN 1 and LAN 2. So now this R3 become an active router. So just we will go to R3 and we will verify that. And here we will give the show command, show standby. Just you press up arrow, or you can type this command, show space standby, then press enter. And here we can see its state is active. So that means R3 is active now. Its virtual IP address and all other details we can see. Yeah. Next we will go to step 3, restore the link to R1. Reconnect R1 to S1 with a copper straight through cable. Okay, execute a trace from PC-B again. Before that we will connect. We have to choose copper straight through. From S1 we'll connect to G0/2 to R1 G0/1. Okay, next execute a trace from PC-B to the web server. You may need to repeat the trace to see the full path. Okay, again we will go to PC-B command prompt and press up arrow from keyboard again, and we can see the trace. It will go to 192.168.1.1. okay, let me see the link is up or not. Yeah, it's up. And here we can see the trace result. Now we can see it goes to R1, then to R2, then to the internet, then it goes to our web server. Yeah, now R1 become active router because we given that command preempt, right? Next is what path is used to reach the web server. Yeah, and now it used from PC-B to web server through R1, right? PC-B, S3, S1, then R1, then R2, then internet, then to this web server. If the preempt command was not configured for the HSRP group on R1, would the results have been the same? No, obviously not. Because this R3 will remain as active router, and we get the trace through PC-B, S3, R3, R2, internet, then web server. But here in this case, we given this preempt command in this R1 for this interface G0/1. So once this interface become up, R1 will become the active router. Okay, so in this video we discussed about CCNA version 7 packet tracer activity, HSRP configuration guide. Here we can see our completion status 100%. Now dear friends, if you have any doubt, any suggestions regarding this packet tracer activity or any other technical support needed, you can comment or you can visit our website to contact our team. Link will get from the description below. Also, if you like our video, give a thumb and share with all your friends. Stay tuned for the future videos. Thank you.